Hello. So today we are going to understand the concept of quantum numbers. So there are four different type of quantum numbers. The first we are going to see is principal quantum number. It is represented with the small n symbol. Who proposed it? It was proposed by Bohr. It was proposed by Bohr. And it simply identifies shell. Okay, what its role? Its function, its role is it identifies shell, or you can say orbit. Okay, it determines size and energy of an orbital as well. It determines size and energy of an orbital. This n principal quantum number, it assumes all the positive integral values. It assumes all the positive integral values. That is, small n can be equal to 1, equal to 2, 3, 4, and so on. And for every value of n, it designate a particular shell. For example, if n equal to 1, then we can simply write we have K shell. So n equal to 1 means K shell. If n equal to 2, it means L shell, and M, N, and so on. So it simply identifies shell and assumes all the positive integral values. For every value of n, we have K, L, M, N, and so on. These shells, right? Now, how to determine the number of orbitals in nth shell? That's very important. So, very, very important concept. It will be asked in the AP exams, MCAT, college OChem, any type of exams. They can ask you find the number of orbitals in the nth shell. In the nth shell, and it simply is equal to n square. Very, very, very important. Okay, so if anyone asks you how many number of orbitals in the fourth shell, then what would be your answer? It's 4 square. 4 square means 16 orbitals are there in the fourth shell. So we simply have to do the n square, and it gives us the value of number of orbitals in the nth shell. And let's suppose if someone asks you how many maximum number of electrons can be possible in the nth shell. So every orbital contains maximum of 2 electrons. We can simply double it, right? So we can create a formula as well. Maximum number of electrons in the nth shell. And it is equal to 2n square, because it simply is the double, right? Because every orbital contains 2 electrons. That is why 2 times n square. That is why we have created this formula. Maximum number of electrons in the nth shell equal to 2n square. So if we have to talk about how many total electrons are there in the fourth shell, means what would be the maximum number of electrons in the fourth shell. What is the answer? Can you tell me that in the chat box? Maximum number of electrons in fourth shell. So answer is 2n square, means 2 into 4 square. Answer is equal to 32 electrons can be possible in the fourth shell. Okay, all right. So this is how we can express the principal quantum number, which simply tells us the shell. Okay, it identifies the shell or orbit. Now let's move towards the next quantum number, which is called as azimuthal quantum number. Very, very important. It is also called as angular momentum quantum number, also called as angular momentum quantum number. Okay. So, what does this angular momentum quantum number signifies? Actually, it is represented with the symbol called as small l. Okay. So, since n tells us the shell, L simply identifies subshell. Okay. It identifies subshell. And it also takes the values. Let's take the number of values we have. It assumes all the integral values, from 0 to n minus 1. This is how we can see the basically the values, right? 0 to n minus 1. So for example, let's say we have n equal to 3. So what would be the value of L? L is equal to 0 to 3 minus 1 means 2. So we have these three values, which is 0, 1, and 2. Is it clear? Now, with this, let's see if we have these values of L, which is equal to, let's say, 0, we have 1, we have 2, we have 3, and so on. What would be the designation of subshell? Designation of subshell. So we have 0 means we have S subshell, 1 means we have P subshell, 2 means we have D subshell, 3 means F subshell, and so on. So L simply assumes these values from 0 to n minus 1, and it tells us the subshell. Okay. N identifies the shell, L identifies the subshell. Clear? Okay. So basically, we can see here the value of L also depends upon the N as well, right? And L has other significance as well. L determines shape and energy of an orbital. Very, very important term. L determines the shape and energy of an orbital. Shape and energy of an orbital. All right. So this is how we can calculate the azimuthal quantum number. So with the help of L, we can also calculate a few other parameters. Let's say if we need to calculate number of orbitals in a subshell. Number of orbitals in a subshell. How do we calculate? It is equal to 2L plus 1. Let's say if we have D subshell. D subshell. Now for D, L is equal to what? 2. So let's calculate the number of orbitals. So number of orbitals is equal to 2 into 2 plus 1. That means 5 different orbitals are there. Okay, so D have 5 orbitals. We all know that. What are those orbitals? This is dxy, this is dyz, this is dxz, then dx square minus y square, and finally we have dz square. So this is how we can calculate the number of orbitals in a subshell. Now, accordingly, we can also calculate the maximum number of electrons as well. And it's very simple, just twice the number of orbitals, because every orbital contains the maximum of 2 electrons, right? So you can do this, maximum number of electrons in a subshell. Maximum number of electrons in a subshell is equal to 2 times 2L plus 1. So this is how we can calculate the maximum number of electrons in a subshell as well. Okay. Now moving forward to the third quantum number, which is called as magnetic quantum number. It is denoted by the symbol small m. So what is the significance of m, magnetic quantum number? It determines orientation of an orbital. It determines orientation of an orbital. Okay. So what is the orientation of an orbital? Means basically the different kinds of orbitals. Okay. The value of different kind of orbitals is basically been given by this m, magnetic quantum number, and it also assumes the values. Let's write about that. It assumes all the integral values from minus L to plus L, including 0. Okay. So let's say if L equal to 2, as we have already seen, L equal to 2 means D subshell. Okay. So what would be the possible values for M, magnetic quantum number? It is equal to minus 2 to plus 2. So we have minus 2, minus 1, 0, plus 1, and plus 2. Look at that. These 5 values means we have 5 different orbitals in the D subshell. Very, very easy. All right, that's clear to you. Now, the last one is spin quantum number. So it simply determines the spin of an electron about its own axis, right? So you can see here whether it rotates basically clockwise or anti-clockwise. It simply determines the spin. It determines spin of electron about its own axis. Okay, what are the two possible values? Either it can rotate clockwise or it can rotate anti-clockwise. So that means the two possible values are plus half and minus half. Okay, so these are two spin states. Two spin states of an electron. Either it can spin clockwise or it can spin anti-clockwise. So in this video, we have seen the 4 different type of quantum numbers, which is principal, azimuthal, magnetic, and spin quantum number. In the next video, we will see how to write electronic configuration of atoms, and then we will try to understand that why certain elements have some exceptional electronic configurations because of the stability of half-filled and fully filled electronic configurations. See you in the next video. Thank you so much.